Betul, boleh saya tekan?
Cikgu ni lah, Cikgu Rizal.
Okey, dah live.
Dah boleh start? Dah live. Okay, Assalamualaikum dan salam sejahtera semua para guru, ibu bapa dan anak-anak pelajar sekalian. Bertemu kembali di Pusat Tuisyen AYU Usaha-Sama E-Didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Untuk memperoleh keberkatan dan salam sejahtera kita pada pagi yang indah ini, marilah kita membaca umul kitab Al-Fatihah. Pusat Tuisyen AYU Usaha-Sama E-Didik Malaysia dan Kelab Guru. Amin, amin, amin ya rabbal alamin. Apa khabar semua? Cikgu harap semua berada dalam keadaan baik dan bersedia untuk meneruskan kelas kita pada pagi hari ini. Cikgu percaya anak-anak semua dah tak sabar untuk meneruskan kelas kita kali ini. Untuk makluman semua, kelas kimia kita pada pagi ini adalah kelas yang ketiga daripada 13 kelas yang akan berlangsung hari ini. Anak-anak boleh rujuk jadual Pusat Tuisyen Percuma ini di www.academyyoutuber.com. Okey, cikgu mulakan sesi ini dengan memperkenalkan diri cikgu dahulu. Saya Cikgu Zanaria Abdullah aka Cikgu Zana selaku moderator pada pagi ini. Dan kita sedang bersiaran langsung dari channel Cikgu Mawar. Mesti ramai yang sudah tahu. Siapa yang belum subscribe, sila tekan butang subscribe sebagai tanda sokongan kepada Cikgu Mawar. Nama sebenar Cikgu Mawar adalah Nik Mawar Hanifah binti Nik Hassan dari Pusat Tingkatan 6 SMK Sultan Abu Bakar, Kuantan. Cikgu Mawar berpengalaman 14 tahun mengajar subjek kimia STPM. Dan pagi ini Cikgu Mawar akan mengajar tajuk Phase Equilibrium Non-Ideal Solution. Kelas ini akan berlangsung lebih kurang 1 jam. Dengan itu, pastikan anak-anak mengikuti kelas ini hingga akhir. Izinkan juga cikgu memperkenalkan guru-guru yang sempat bersama di konti pada pagi ini. Selain daripada Cikgu Mawar dan saya, ialah Cikgu Naini selaku host controller, Cikgu Naini, dan Cikgu Rizal serta Cikgu Lau sebagai pemerhati. Sebelum kita teruskan kelas kimia STPM ini, ingin cikgu ingatkan anak-anak dan para penonton untuk menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tuntunan umum sekiranya ingin menghantar komen di ruang chat. Sila fokus pada isi pelajaran yang akan disampaikan oleh Cikgu Mawar dan anak-anak bolehlah kemukakan soalan dan sebarang kemusykilan di ruang chat serta menjawab pertanyaan Cikgu Mawar dengan pantas. Saya percaya semua yang hadir kelas pada pagi ini merupakan pelajar-pelajar yang cemerlang dan mari kita tunjukkan disiplin yang terbaik. InsyaAllah moga kelas kita pagi ini dapat dimanfaatkan sepenuhnya oleh anak-anak sekalian. Tanpa membuang masa lagi, saya serahkan kelas ini kepada Cikgu Mawar.
Okey, Assalamualaikum dan salam sejahtera. Okey, terima kasih diucapkan kepada moderator Cikgu Zana. Alright, terima kasih juga diucapkan kepada semua team member yang ada pada hari inilah. Okey, first Cikgu Naini, Cikgu Rizal dan Cikgu Lau, Cikgu Bibi Lau ya. Okey, so for today, I will teaching about equilibrium. Okay, so before that, I will introduce myself. Okay, my name is Mawar Hanifah binti Nik Hassan. Okay, my school SMK Sultan Abu Bakar, Kuantan, Pahang. Alright, teaching experience. Okay, have been teaching chemistry SPM and STPM. Alright, my study experience. Okay, my bachelor's and master's degree. Okay, in UTC, and currently I'm doing my doctorate degree in UPM. Alright, okay, and do visit my channel, Cikgu Mawar Kimia. Okay, so don't forget to subscribe after the lesson. Alright, so here is my team, my chemistry team, which conducted by Cikgu Shahnon. Okay, we have Cikgu Bibi Lau, okay, on the stage here. Okay, and we have Teacher Tang. Okay, and then for bio team, we have Cikgu Faiza, Cikgu Naini on the stage here, right, and also Cikgu Fatia. Okay, we also have a mathematics team conducted by Teacher Im, okay, and Cikgu Aileen, and also Cikgu Zana here. Alright, okay, and then we have Madam Fizi for perakaunan and Cikgu Yati too. Okay, and not forget that we also have another STPM subject. Okay, we have PA Muat Pengajian Cikgu Rizal, okay, here for today. Okay, and perakaunan STPM. Alright, okay, so don't forget to check the latest schedule for at www.academytuber.com. Alright, okay, for today lesson, okay, I will teach about equilibria. Okay, this is the chapter 6 of STPM syllabus. Okay, and for equilibria, it consists of 4 subtopic. Okay, which are the phase equilibria is included in the 6.4 subtopic. Alright. Okay, so this is the syllabus, and okay, then I think that for matriculation, they didn't cover the phase equilibria. Alright. So this is the syllabus. So I will cover about interpreting the boiling point composition curve. Right? Okay, then. Okay, so when we talk about the phase equilibria, okay, we will apply the Rod's law. Okay, Rod's law. So what is Rod's law? Who is Rod's law? Okay, so this is the Rod's law, which is who the invented the Rod's law, named Francois Mary Rod. Alright, say, what is the rod say? Okay, it states that if two miscible liquids, which is A and B, are mixed to form an ideal solution, the partial vapor pressure of A is equal to the product of the mole fraction of A and the vapor pressure of pure A at a given temperature. Okay, like this. Okay, we have a two pure A and pure B. Okay, when we mix together, so it will form solution. So if it's obey the Rod's law, we can calculate using PA, which is partial vapor pressure of A, equal to XA mole fraction of A times to the P naught A, which is vapor pressure of pure A. Same goes to when we calculate the pure B. Alright, this is when we obey the Rod's law. Okay, so it will form the ideal solution. Alright. Okay, next. Okay, after MISI, we form A plus B lah. Right, and for evaporation to be occur, if we didn't close the container, okay, which is if in open container, okay, vapor molecule will diffuse away. All the molecule will diffuse away, and at the same time, the liquid will dry up. So, when we talk about equilibrium, okay, make sure that our system is in closed container. Alright? Okay. So when we talk about for equilibrium 2, okay, so we must focus on vapor pressure. It involves the vapor pressure. Okay, what is vapor pressure? Okay, vapor pressure is the pressure exerted by vapor molecule on the surface of a liquid here. Right? So for the surface, so this is the container. Okay, so it have a mixing of a solution in the container. So this is the molecule involved. So at the surface of the molecule of the liquid, there will exert a vapor pressure. Okay, so now, okay, let me see the simulation. Alright, when we heat in a closed container, it will evaporate. Okay, when the evaporation occur, okay, so it will reach until the equilibrium. Alright, so during the
Line.
Okay, it shows
Okay, there seems to
negative
be a
deviation.
technical problem here, line problem. So can we wait for a while? Okay, Cikgu Mawar is back. Is Cikgu Mawar back? Are you okay? Cikgu Mawar?
Okay, I'm here.
Okay, yeah,
Okay, tak?
right. Okay,
Can
we can hear you now.
everyone listen to me?
Yeah, we are listening.
Can
We are
everyone
listening.
listen? Alright. Alright, can I
Cikgu
continue?
Mawar, proceed. You
Alright.
can proceed.
Alright, so I will continue. Okay, so I continue my lesson. Right, so for now is if you got the graph is like this, so this is the negative deviation. Alright, so for the ideal solution, okay, it's obey the Rod's law. We got ideal solution. Okay, if this both kind of a graph, so that's deviate from Rod's law. Okay, non-ideal solution. Alright, so next one. Okay, so when we talk about the vapor pressure, we can relate it with boiling point. So for this graph, we can see that this is the B, the pure B one. So it shows that the B is a higher vapor pressure compared to A. So this shows that the higher vapor pressure, the lower the boiling point. Okay, so it's inversely proportional. Okay, if the higher boiling point, it will lower the vapor pressure. Okay, then, okay, non-ideal solution, why deviation occur? Alright, why deviation occur? Okay, so we can see in the four assumption. They have four assumption why deviation occur. Alright, for the first thing is, okay, let's see the diagram here. Okay, we have two pure liquid here. Okay, we have a beaker A, we have water, example of water. Okay, beaker B, we have a propanol. Okay, for this both liquid, okay, if intermolecular forces between particles differ, okay, which is for water, okay, for water we have hydrogen bonding, okay, while for propanol we have weak van der Waals forces. Okay, when the two pure liquid, which will be mixing, okay, and then it both have a different intermolecular forces, so it's higher to form deviation from Rod's law. Okay, then T total, which is total vapor pressure, do not same to ideal solution. Okay, basically for ideal solution, we can calculate the P total by using the Rod's law. But for non-ideal solution, we can't calculate. Okay, because when we measure the exactly total pressure, okay, it didn't say, this do not say with a Rod's law. Alright, so we get the different total with the ideal solution. Okay, the third one is V total, which is total volume do not same when mixing. Okay, suppose for water which consists of 20 cm cubic, when we mix up to the 25th cm cubic of propanol, so suppose we get 45 cm cubic, is it? Alright, for ideal solution, yes. Okay, but okay, for non-ideal solution, okay, maybe if we get 40 cm cubic, which is below from the ideal solution. Or maybe we can get 50 cm cubic, which is greater than ideal solution. So it shows that it's deviate from Rod's law. Okay, and then the fourth one is the heat change. Right, heat change is for ideal solution. Okay, we can measure that enthalpy change is 0. Okay, why? Because heat release is equal to heat absorbed. Okay, so we get it 0. Okay, but for ideal solution, heat release is didn't equal to the heat absorbed. Alright? Okay, so for deviation for Rod's law, it consists of two types of deviation. Okay, we have negative deviation and also we have positive deviation. Okay, and this kind of deviation can be shown into two types of graph, or we call as a composition curve. Alright, so the first one we can show into vapor pressure composition curve, and we can show into the boiling point composition curve as well. Alright, okay, and then okay, this is the graph, okay, that we can draw here. Okay, we have boiling point and we have vapor pressure composition curve. Alright, so for unit, here we can see we can show into boiling point or vapor pressure. So depend on the question asked. Okay, in exam you must refer to the what is it? Is it boiling point or vapor pressure? Okay, so now I want to explain in terms of positive deviation first. Alright. Okay, is how you want to memorize it. Okay, now positive meaning plus. Okay, plus, positive. So positive plus. Okay, ingat. Positive, okay. If we get, for boiling point, for boiling point, if we get the smiley face. Alright, boiling point for positive deviation, we will get a smiley face. Alright, okay. And then, for the hair, the upper one is a V, vapor, represent the vapor. And the face shape, L, represent the L, okay? Opposite L lah, opposite L lah. Okay, so what is this? Alright, so let's we see the graph, the composition curve. Alright, so for boiling graph, for boiling composition curve, the shape of the graph must be smiley face. Like this, smiley face. Don't forget for positive deviation, we get the smiley face, right? So smiley face. And then we draw like this. Okay, so from this graph, we can see that for A, pure A will mix it up with pure B. And then we form this kind of graph. And this graph also represents that boiling point, of pure A is 60 degrees Celsius. Why pure B? The boiling point is 100 degrees Celsius. Alright, what? So vapor. The upper one, the up one of the graph ni, that one is the represent of vapor state. Guys, vapor state is a gas. And then the below one, the bottom one is a liquid. So ingat rambut, hair. Hair is a V1. V1 is represent vapor. The bottom one is a liquid. Alright, so this is how you sketch for boiling point. Okay, what is this? Okay, so this is for vapor pressure. So it's the opposite shape. For vapor pressure, once we draw the vapor pressure composition curve, we will get the sour face. That will be opposite lah. Alright, so liquid over vapor. So that's why I just suggest to you all students that just memorize the one kind of graph only. So this face, this smiley face only. So at the same time, you can draw the another graph as well. Alright, this is the azeotrope mixture. Azeotrope or azeotropic mixture. So you can answer in two types of name lah. You can write azeotrope, or you can name it as the azeotropic mixture. Okay, so this is the azeotropic mixture. Compared to the ideal solution, for ideal solution, when we're mixing up together, in the container it only consists of A and B, right? While for non-ideal solution, when we mixing up the liquid, then we will get the three types. We have A, we have B, and we have azeotrope as well. Alright, what is azeotrope? It's a solution of two or more liquids that boil at a constant temperature and composition of the mixture does not change upon distillation, which is vapor and liquid have the same composition. So at this point, azeotropic mixture, so this kind of point, so vapor and liquid have the same composition. And very good for azeotrope because it cannot be distillate over distillation. We cannot separate it. Alright. Okay. Next. Alright. So this is the graph. The composition curve. Actually for non-ideal solution, you must know how to sketch the four types of graph. Because for positive deviation, we can sketch in terms of boiling point composition curve. Also vapor pressure composition curve. and as well as for negative deviation. We must draw in terms of boiling point or vapor pressure. Okay, so you just memorize this one. Right? So for positive deviation, which is a smiley face, okay, you must know that it has minimum boiling point. Okay, minimum boiling point is referred to the isotope of boiling point of isotope. Okay, so for vapor pressure, okay, we have a sour face. Alright, for negative deviation, okay, if a positive deviation for boiling point is a smiley, so it will opposite. Alright, okay, and then okay, for negative deviation, you must take note, okay, that it has a maximum boiling point over here, right? Okay, which is represent the isotope has the highest boiling point here. Alright, okay, and then for vapor pressure shape, okay, which is the smiley. So you just memorize this one. So at the same time, you can draw all the four, right? Okay, so now, okay, I want to explain about positive deviation first. Okay, for positive deviation, okay, I will explain through the example. Okay, I give you two types of pure liquid. Okay, example, acetone. Acetone is a propanon in a ketone group. Okay, acetone is the same name as a propanon. Okay, which is AA, pure A. Dalam ni ada acetone only. Okay, and this one is the ethanol. Okay, and then, okay, this is the acetone structural formula lah. Okay, C double bond O CH3. Okay, so what is the intermolecular forces? Okay, so this is the intermolecular forces exist, okay, among the molecule, right? You see the ethanol. Okay, this is the ethanol, C2H5OH. So it will form the intermolecular forces here, right? Okay, so this is the we call as a weak van der Waals forces. Okay, among acetone it consists of weak van der Waals forces. Okay, while ethanol consists of hydrogen bonding. Okay, ethanol, right? Hydrogen bonding. Okay, so please memorize. Please flashback. Okay, what is a hydrogen bonding class? Okay, student. So hydrogen bonding. Okay, this is the hydrogen which covalently bonded to highly electronegativity of atom, okay, which is NOF, and this H, okay, will form intermolecular forces to highly electronegativity too, okay, which is NOF. Okay, so make sure that you proper understand about hydrogen bonding lah. Okay, so and then okay, when we mixing up together, so in the container, it exists A, B bond, okay, which is propanol, okay, or acetone, we bonded with ethanol, so it will form weak van der Waals forces. Okay, you see here that, okay, if you see here that weak van der Waals forces is a weaker intermolecular forces compared to hydrogen bonding. So what can we deduce here? Okay, that, alright. So, okay, so here is the okay, molecule of the POA and POB. Okay, after kita mixing up in a closed container, finally it will breaking up. How? It will breaking up. So this one finally will be breaking up. Okay, it will breaking. Okay, this one will finally it will breaking up. Okay, so the same goes to all the intermolecular forces of the molecule. Okay, it will breaking up. Okay, so then, okay, the molecule form here is the okay, sorry, I want to find my cursor. Okay, so good. Okay, so now this is the molecule, the solution, which is propanol bonded with alcohol. Okay, ethanol, so we form AB. So what we can see here, intermolecular forces of AB, okay, which is the solution, is a weaker intermolecular forces, weak compared to BB. Okay, weak van der Waals forces is weaker than hydrogen bonding. Right, so this will form positive deviation. Okay, second is the P total. Okay, P total. Okay, we must be greater than P of A plus B. Okay, and for volume, V total will be greater than VA plus B. Okay, and the heat will be positive, so it shows it is an endothermic, which is heat is absorbed. Okay, so we can say that brick bond is greater energy needed than foam bond. Okay, because hydrogen bonding is a stronger bond compared to van der Waals. So it's very higher energy to break this bond compared to weak van der Waals forces. So finally, when the question asks about positive deviation, you must write down the these four assumption, right? Okay, these four assumption, and nak senang ingat is a positive. You will get all the solution here greater. P total will be greater, V total will be greater. Okay, and heat is absorbed, which is positive, endothermic. Okay, it's a very positive one. So we get all the greater. Okay, and then the intermoleculars will be weaker lah. Okay, then. Okay, that one is a weak van der Waals forces. Okay, now, okay, how to compare between these two kind of deviation. Okay, for positive deviation, okay, don't forget the smiley face, boiling point curve. Okay, we get the smiley face. Okay, for the smiley face, and make sure that the intermolecular forces of AB is weaker than BB. AB, okay, you ingat that solution in the closed container after mixing up, it will be AB. Okay, BB refer to the pure molecule. Okay, either ethanol, okay, either acetone, okay, the pure one in the bitter one. Okay, and then P total. P total must be greater, okay, then solution, then either solution. Okay, P total must be greater. Okay, and then enthalpy change will be absorbed, heat will be absorbed. Okay, because positive kan. Okay, so the example here, okay, we have ethanol and water. Okay, we have propanol and water and benzene and ethanol. Okay, this is for positive deviation. Okay, while for negative deviation is all opposite. Alright, so you just memorize the one of the assumption, then at the same time you can write for the negative one. Okay, so you just must know the example lah. Example of negative. Okay, we have HCl and water. Okay, we have nitric acid and water. Okay, we have trichloromethane and propanol. Alright, which is for negative deviation. Negative is we will get the sour phase because negative. And we have heat is release. Heat release is like kita panas lah, kita marah. Okay, kita panas. So heat is release, so it will be marah, so it will be sour phase. Okay, that one is a negative deviation. And at the same time, P total we will get smaller. V total also we get smaller. Okay, because the stronger of intermolecular forces, and it will be really very high energy needed to break, okay, the AB bond. So that's why we get the P total and V total lower. Okay, right. Okay, so any question? Cikgu Zana so far?
So far, there's no question, Cikgu Mawar. I think can we...
Oh, can I continue?
I think it's time for us to take a break first for the advertisement.
Okay, right. Okay, go ahead.
Okay. Cikgu Rizal.
Semua sekolah ditutup hingga cuti akhir tahun 17 Disember 2020. Anda tak cukup bahan? Tak ada rujukan? Tak faham? Anda nak tuition tapi PKP? Jangan risau, kami di Akademi YouTuber dengan kerjasama Kelab Guru Malaysia dan e-Didik Malaysia mengadakan kelas tuition online. Semua peringkat ada, semuanya secara percuma. Video PDPC pun ada. Apa ditunggu lagi? Layari www.academyyoutuber.com. Dibawakan kepada anda oleh Akademi YouTuber.
Okay, Cikgu Mawar, you can proceed. Okay.
Alright, okay, so now, okay, we continue our lesson. Okay, now, okay, we already studied about all the solution of non-ideal solution. Okay, but now how to separate the mixtures of a two miscible liquid. Okay, miscible liquid is referred to the terlarut campur liquid yang kita boleh nak campur together lah. Okay, so this is already reached the equilibrium. So now how we can separate these both liquid? Okay, so okay, how to separate it? Okay, so now is we can use bifractional distillation. Okay, bifractional distillation. Okay, so what is fractional distillation? Okay, separate component of liquid mixtures based on their boiling point. Okay, so this is the apparatus that we use to fractional distillate, okay, the mixture. Alright, what is the comparison, okay, between ideal solution and non-ideal solution? Alright, so okay, for ideal solution which contain of A and B liquid, so when we separate the ideal solution, we can get pure A and we can get pure B as well. Okay, but for non-ideal solution, when we separate it, okay, we only get either one. Okay, we only get A or we can get B. Right? At the same time, we can get azeotropic mixture. So that one is the comparison between ideal solution. Alright. So here, okay, let's we explore the curve. Okay, how to draw the curve. Okay, basically when you are asked how to sketch the curve. Okay, the first one is it must have y and x axis. Okay, y and x axis. Okay, for y axis, okay, it can be put either boiling point, okay, or vapor pressure. Okay, for boiling point, okay, kadang-kadang that dalam exam it put the temperature. Okay, temperature is represent boiling point lah. Okay, and then for for x axis, okay, it can put either percentage of composition of A or it can put mole fraction. Okay, which is for composition of A in percentage, you can put from 0 to 100. Okay, so for this arrow represent that A is 100 here. Okay, so we can see that pure A have a boiling point of 78 degrees Celsius. Okay, while for B is the opposite one. For 0 to 100 B here, so B, the boiling point of B represent 55 degrees Celsius. Right. Okay, so this is the isotrope boiling point, which is the minimum one. Okay, the minimum boiling point of isotrope, which is 45 degree. Okay, so okay, next. Okay, right, for equilibrium phase, okay, phase diagram here. Okay, we have two region. Okay, we have region 1 here, we have region 2 here. Okay, so when we want to start our distillation, okay, which is fractional distillation, okay, let's say that okay, C1. Okay, what is C1? C1 is let's say we want to start our distillation from C1. Okay, C1 is represent the 50% of A. Okay, at the same time, how many B? So B consists of 85% of B. So C1 represent the mixture is 50% of A and 85 of B. Okay, so you must know this thing now. Okay, so let's distillate the C1. Okay, so if we occur like this, so below 1 is the liquid. So now is liquid with turn to vapor. So this is boiling process occur here. Okay, and then going down, vapor turn to liquid, which it will condense. So it will boil, condense, boil. Okay, finally it will reach the isotrope point. Okay, so for C1, the distillation only occur in the region 1. Okay, only occur in the region 1. Okay, whereas the product is only can be either isotrope or pure B because the distillation occur in the region 1. Okay, so you tak payah tengok dari region 2. Alright, okay, for C1. Okay, so what is the product form which is distillate? What is the distillate will be formed here is a isotrope. Okay, so if C1 is fractionally distilled, okay, first distillate, okay, would be isotrope. Okay, which is mixture of A and D lah dalam isotrope lah. Okay, and then the second distillate which is residue or the remaining liquid in the container supposed to be pure B. Alright, so C1 is only from the isotrope or the pure B. Okay, which is when it reach 55 degree. Okay, so pure B will left over lah. Okay, bila keluar lah dia akan keluar daripada distillation tu. Okay, second example here. Okay, if we start our distillation at C2, composition of C2. Okay, C2 represent 70% of A. Okay, so in the container, okay, how many percent of B? Alright, so 100 minus 70 equal to 30 lah. So in composition 2 consists of 70% of A and 30% of B. Okay, now we start distillate. Alright, so and then we bought, we condense, we bought. So what is the first distillate at C2? Okay, okay, student, any student can answer this question? Okay, for C2, what is the first distillate? Okay, agak apa first distillate? Because C2 only involve the region 2 sahaja. Okay, only region 2. So the product supposed to be isotrope, okay, or pure A. Okay, any answer? Any answer? Cikgu Zana ada tak?
So far, no answer.
Okay, fine. Okay, didn't have. Okay, so the first distillate when we do the fractional distillation over C2, so we will get the isotrope as a first distillate, right? And the residue in the container, okay, will be pure A. Okay, because the distillation process, the fractional distillation, okay, only occur in the region 2. Okay. Alright. Okay, if we start distillate at C3, composition of C3, okay, you can see that C3, okay, C3 consists of 40% of pure A, okay, and at the same time, okay, what is the composition of C3? Okay, we have 60% of B, right? Okay, then, okay, when we distillate, okay, so over here, as we know, that is only have isotrope. Okay, it only have isotrope. Okay, so that, okay, the distillate is only produce isotrope. Okay, which is sole distillate. Okay, we only produce isotrope. Okay, this is how you tackle the fractional distillation question. Okay, you must know where to start your distillation process, which composition. Okay, C1, C2, C2 or any point. Okay, so okay, then I continue. Okay, so we go to the example here. Okay, we have an example here. The question is a pure hydrochloric acid is a colorless liquid which form an isotropic mixture with water. Okay, aqueous hydrochloric acid shows a negative deviation from Rod's law. Okay, why? So explain why it is negative deviation among these two kind of pure liquid. Okay, why? Okay, so the first one, when you got the question, okay, we got the question, you must identify the intermolecular forces of both liquid. Okay, so you involve of water, you involve of HCl, which is hydrochloric acid. Okay, so consider the intermolecular forces in the both molecule. Okay, you have POA here is have a intermolecular forces. Here, okay, HCl. So this is when we mixing up, okay, the solution, okay, it will form hydrochloric acid, A plus B. Okay, so it dissociate in water. Okay, so what kind of IMF here? Intermolecular forces. Okay, for HCl, which is A, liquid, okay, it is a weak van der Waals forces. Okay, while for B is hydrogen bonding. Okay, while in A and B, since it's ionized in water, okay, so it will form strong electrostatic force. Right, so it will form the strong electrostatic force. So from these three, okay, we can say that which intermolecular forces is the stronger one. Okay, which one is the strongest? So the strongest one is a AB, okay, which is the solution. Okay, the solution is stronger one. Okay, so you can say that, okay, this is how to answer. Okay, which is the interaction, okay, between hydrochloric molecule and water molecule is stronger than interaction between pure hydrochloric acid, which is consists of van der Waals tadi, okay, and pure water molecule, which is hydrogen bonding. These both are weaker than solution of hydrochloric acid and water because it forms strong intermolecular forces. Hence, the vapor pressure is lower than expected. Because when the stronger one, the strong bond, so it need higher boiling point. Okay, so that's why vapor pressure lower. Higher boiling point, we have a lower vapor pressure. Okay, so now, second question. Okay, sketch a boiling point, composition diagram for aqueous hydrochloric acid, given that hydrochloric acid boiled at 85. Okay, boiled at 85. Okay, 85. So the keyword here is 85. Okay, and then azeotropic mixture containing 22.2% of hydrochloric acid by mass, boiled at 108.5 degree at 101 kilopascal. Okay, 101 kilopascal is represent that this process is occur in the 1 atm. 1 atm equal to 101 kilopascal, which is room temperature pada room temperature. Okay, so now, okay, when we bought, okay, we do the fractional distillation. Okay, now we start to sketch. Okay, we start to sketch here. Okay, we start to sketch. Okay, so now is we see the keyword here. So hydrochloric boiled at 85. Okay, so we put here because the composition is starting from O to 100 of HCl. Okay, meaning that this arrow is represent boiling point of HCl. So HCl 8 negative 85 here, below 1 negative. Okay, and then azeotropic mixture content of 20. So azeotropic mixture, okay, you must know that is put in the middle. It's located in the middle. So we put 20% of HCl. So somewhere here. Okay, so somewhere here because only 20.2% of HCl. Okay, for the azeotropic mixture. So another balance is water, right? The water tadi. Okay, then azeotropic mixture, okay, have a temperature. This boiled at 108.5, which is represent boiling point of azeotrope. Okay, this is the boiling point of azeotrope. Alright, so okay, somewhere here lah, somewhere here. Okay, so water is for sure 100 degree, we boiled for 100. So at the left side is belong to 100% of water. The right side is belong to HCl for 100%. Okay, so now, okay, here is the composition of the azeotropic mixture, which is it have, okay, this one is a negative. You must remember that boiling point for negative deviation must be sour phase. So suppose this diagram mesti jadi sour. So this shows that azeotropic have a maximum boiling point because of the sour phase. So isotrope is the maximum boiling point over here. Alright. Okay, so then we can sketch like this. Okay, from 100, okay, isotrope, okay, and then negative 85. So we just sketch it over like this.
Okay.
Alright. Okay, and then continue.
Cikgu
Alright.
Mawar,
Okay, so we
I think your slide macam lagging. Your slide is lagging. The students can't see what is your you are drawing, isn't it?
Okay.
You are sketching the graph,
Is
isn't
it
it?
now?
I couldn't see any. I couldn't see any graph.
Yeah.
I could only see the axis. But not the
Yeah.
curve.
Okay, wait. Okay, is it okay now?
There's no curve.
No
You're
graph.
sketching a curve, right?
Kind of. Yeah. So not present there.
It's lagging.
Wait.
Mama is lagging. Okay, now I can see the
Is it
curve
okay
already.
now?
Yeah. I see the curve already.
Okay. Is it okay? My voice, is it clear?
Yeah, I can see the curve already.
All right. Okay.
I think your background is what do you call it?
Is it okay now?
Dragging your internet line.
Yeah, maybe my internet
Yeah.
so strong because hujan lebat dekat outside there.
That's why it's lagging.
Okay. So now is it okay?
Yeah, I could see that. Yeah.
Okay.
Yeah.
Right. So now is the okay. Just proceed. Okay. So now is finally okay. You can sketch like this lah. Okay, you can sketch like this. So this you akan dapat format lah. Okay, when all the value is sketched out in the graph, in the composition curve, okay, and you draw it correctly, okay, you put the temperature correctly, and you put the isotropic correctly, and the axis, if a label correctly, so you will get the full mark for this. And don't forget that the face on the top and the bottom of the graph. Okay, so now is it okay, right? Okay, so now. Okay, C question, for the C question. Okay tak Cikgu Zana? Is it okay, Cikgu Zana?
So far no question, only that the students commented they can see your slide just now, and it's okay now.
Alright. Now okay, alright, okay, very good. Okay, so now is state the changes, okay, which occur in the composition of the residual liquid and the distillate when a solution containing 60% of hydrochloric acid is continuously distilled. Okay, so now we have a graph. Okay, but now is we want to do the fractional distillation. Okay, and the distillate is starting at the 60% of hydrochloric acid. Okay, so where we should start our distillation? It says that 60% of hydrochloric acid, so it's somewhere here lah. 20 here, over here, so that one is 60 something here. Okay, so we put. Alright, so don't forget that our region involved for this question is only region 2. Because 60 is for the second region ni. Okay, so then okay, so 60, so we just do the fractional distillate over here. Okay, we bought, we condense, we bought again. Finally, we get the product. Okay, so
Cikgu
this is the
Mawar,
bias, yeah? Yes.
where is the 60%? Where is the, I'm sorry, I couldn't see the region 2.
Okay,
Did you highlight
is it
any
okay
region
now?
just now? That's in region.
Alright, okay. Okay, that's the region kan? Sorry, I don't know what my, I don't know what happened to my internet line. Okay, so now this is the result. The result which is we get the pure HCl
Okay,
here.
I can see now.
Negative 5. Alright. Okay, so now is the region only involve either HCl, okay, and the isotrope. So what is the answer here? Okay, what is the suppose that will be distilled out? At the first distilled out here. Okay. Okay, so I think that we have not enough time to ask student. Okay, so distillate is pure 100% of HCl. Okay, so we have a pure 100% of HCl as the first distillate. Okay, find the second one, we have the residual liquid. The remaining liquid in the container is a supposed isotropic mixture, which contains of 20.2% of hydrochloric acid. Alright, so if we dish it out at the temperature lah, the previous one, what is the boiling point of the isotropic tadi? Okay, so this is the question, and I don't know we have enough time, Cikgu Zana, to do the objective question.
You've got 10 minutes. I mean, actually 5 minutes.
5 minutes. Okay, so now okay, so I have two objective question here. So I just want to ask the student over there. Okay, the boiling point composition phase diagram for a solution containing liquid mixture of X and Y is shown. Okay, I think it's a bit.
That's the question.
Okay, is it okay now?
I can't see the question yet. It's objective, right? It's still
objective question, right? Okay, I think that is a bit.
It's okay, there's still time.
Okay, hopefully it will appear as soon as possible.
Yeah. Let's pray. Everybody is reading the objective question.
Sorry, I don't know what happened to my internet just now.
Yeah.
Okay, is it there?
Not yet.
Does it appear or not, Cikgu Zana?
No. It's still part
Not yet lah.
It is here. Okay. You can see
it already.
Yeah, you can see the question already.
Alright, so the boiling. Okay, thank you, Cikgu Zana. Okay, the boiling point composition phase diagram for a solution containing liquid mixture of X and Y is shown below. Okay, which statement is true about the phase diagram above? Okay, student. Okay, I give you time to answer this. Okay, before I finish my lesson today. Okay, so we have a X, we have a Y. Okay, 100X meaning that from left to right is 100 of X liquid. Okay, Y from right to left you have 100 of Y. So is it correct that fractional distillation of solution containing 40% Y, yield pure Y, liquid Y and isotropic mixture? Okay, or the solution shows positive deviation from last slide. Is it true? Positive? Okay, don't forget that boiling point suppose have to have a smiley face. So B, for sure, incorrect. Okay, liquid X could be ethanol and liquid Y could be methanol. Okay, suppose to that when it has the same functional group, okay, ethanol and methanol, so it must have the same intermolecular forces. So this C answer is refer to the ideal solution. So the answer is wrong. Okay, D, liquid X is more volatile than Y. Liquid X is more volatile than Y. Okay, this shows that the higher boiling point of X. Okay, when the higher boiling point, it shows that the lower vapor pressure, it is less volatile. So suppose X is less volatile. So the correct one is, okay, student? Any answer, Cikgu Zana?
Any answer, students? We are waiting for your answer. This is just one word answer. Just choose any alphabet A, B, C, or D.
Yeah, just try.
Don't worry about the links will be given at the end of this session. Just answer the question first.
Yeah. What is the answer for the...
At least I want to see one brave student who can answer Cikgu Mawar. Okay, Shubhashini answered A. Shubhashini answered A. Xiao answered A.
Okay, Shubhashini. Okay.
Congrats.
Okay, fractional distillation of solution containing 40%. So 40% of Y. Okay, yield pure liquid Y. Okay, and isotropic mixture. Betul. Okay, for 40% of Y, which is 40% is over here 40%. Okay, so it will distill pure Y and Azeotropic, which is it will occur at a region 1. Okay, region 1. So correct. The answer is A. Okay, last question. Okay, last question today. Okay, the boiling point composition phase diagram for a solution containing liquid mixture of X and Y is shown below. Okay, what is the distillate obtained if a solution which contain equal masses of 1 propanol and water is fractional distillate? Okay, so from this graph, you can see that propanol is from left to right is the 1.0, which is, sorry?
We are interested in the question.
Okay.
Still, okay.
Okay, I don't know. Is it okay?
Not yet.
Still waiting
Yeah. Can you read the question again?
Okay, the boiling point composition phase diagram for a solution containing liquid mixtures of X and Y. Okay, so this is the phase equilibrium of X and Y. X and Y is apa to X and Y? Okay, it says that 1 propanol solution, okay, which is involve 1 propanol and it involve of water as well. So 1 propanol is 1.0 here. So more fraction is from 0 to 1.0. Okay. Okay, is it clear, Cik Zana?
The question is which statement is true, is it?
Sorry?
What is the question? Which statement is true about the phase diagram?
Okay, what is the distillate? Okay, which one is the correct one? Okay, which contain equal masses. The keyword here is equal masses. We want to distillate in equal masses. We have 0 to 1.0. So equal masses meaning 0.5. Okay, the composition contain of 50% of propanol, 50% of water. Okay, we distillate at the equal masses of both liquid. So meaning it will occur at a 0.5 over here. So we start distillate over here.
I think this is the same question just now, Cikgu Mawar. If I'm not mistaken,
okay,
sorry, I'm not sure. Yeah, I think the slide have not been moved yet. It's the same slide.
Okay, it's okay. Okay, it's okay. Then we can stop here, I think.
Yeah, I think we can stop here. Okay. Sorry.
Yeah. Sorry, student. I'm sorry.
Okay. All right. We stop the session now. I'm so sorry, students. The line is not good today. Baru nampak Cikgu Mawar. Okay, let the question be there. Okay, Cikgu, can you give us the answer then? Just give us the answer.
Yeah.
What's the answer? What is the answer, Cikgu Mawar, for this question?
Okay, so this question is a A answer, right? So nanti you can revise the question back. Okay, the answer is A.
Okay, the answer is
okay.
A. Then. All right.
Yeah, then thanks for watching.
Okay.
Sorry for the interruption.
Okay. All right. Alhamdulillah selesai sudah kelas kita pada pagi ini. Terima kasih Cikgu Mawar atas perkongsian ilmu yang amat bermanfaat khusus untuk pelajar yang bakal menduduki SPM kelak. Tahniah diucapkan kepada semua pelajar yang setia bersama kelas pada pagi ini dari awal sehingga ke saat ini dan memberikan respon yang baik sewaktu pembelajaran. Okay, sebelum kita tamatkan sesi siaran langsung hari ini, mohon tutup ruangan cek sebentar dan sebagai tanda penghargaan kepada Cikgu Mawar, sila klik butang subscribe dan juga aktifkan loceng supaya anda tidak terlepas sesi kelas yang seterusnya. Sekiranya anak-anak suka dengan apa yang dipelajari hari ini, sila klik like dan share kepada rakan-rakan di media sosial untuk sebarkan ilmu dan beroleh kebaikan di atas perkongsian tersebut. Okey, dah share dan subscribe. Okey. Sekiranya sudah share dan subscribe, type done di ruang komen dan link saja telah pun diberikan sebagai tanda terima kasih daripada Cikgu Mawar kerana kehebatan anak-anak menyertai kelas tuisyen percuma pada hari ini. Anak-anak boleh tonton semula kelas online percuma ini melalui link Cikgu Mawar atau link yang disediakan di portal AYU. Okay. Jangan lupa kod akses bagi link CD ialah kelas AYU didik. Cantum semua ya, capital letters. Kemudian sila ambil perhatian, link tersebut akan tamat tempoh setengah jam selepas live ini. Pastikan anda guna email didik sahaja. Kesalahan memasukkan email tidak akan dilayan. Harap maaf ya. Dan jangan lupa untuk ikuti kelas tuisyen SDPM matrikulasi seterusnya, iaitu kelas akaun bersama Cikgu Yati malam ini jam 9.30, kelas kimia 7 Jan pada esok hari jam 9.30 malam, kelas matematik bersama Teacher Aileen 9 Jan jam 5 petang, kelas kimia 10 Jan 12.30 bersama Cikgu Shannon, kelas biologi 10 Jan 3.30 petang bersama Cikgu Fatia. Juga diingatkan sekali lagi, semua kelas online percuma ini boleh ditonton semula melalui link cikgu-cikgu tersebut atau link yang disediakan di portal AYU. Jom anak-anak, sila layari portal www.academyyoutuber.com untuk dapatkan info terkini. Anak-anak digalakkan join e-didik junior dan anak-anak pun boleh daftar untuk perjalanan ikon e-didik junior. Dan cikgu harap bantu cikgu untuk sebarkan kelas tuisyen percuma ini kepada rakan-rakan dan guru-guru seluruh Malaysia. Semoga kita mendapatkan manfaat daripada kelas-kelas yang dijalankan. Dan pihak kru pada pagi ini kami mohon maaf atas masalah teknikal itu. Maklum ya, lagging line ya, kita bukan, it's beyond our control, dan tambah lagi dengan cuaca yang tidak mengizinkan, ada tempat yang masih hujan dan ada tempat yang masih mengalami banjir. Moga diharapkan dipermudahkan urusan mereka yang mengalami kesulitan. Okay, terima kasih kepada semua pegawai Akademi YouTuber. Doakan kami terus kuat dan bersemangat untuk membantu dalam membangunkan pendidikan Malaysia. Ingat hashtag bermula percuma, selamanya percuma, insyaAllah. Assalamualaikum. Bye.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma, mestilah Akademi YouTuber.
Dibawakan kepada anda oleh Akademi YouTuber.